Alright, General Chemistry. In this video we will revisit the periodic table, and we're going to discuss the families and groups of the periodic table. On your periodic tables that you use in class, there is this zigzaggy line between boron and aluminum, and then it goes down to aluminum silicon, and it just keeps alternating right and down until it gets to this point here. That is our metalloid line, and that helps us find the major families of the periodic table. To the left of that metalloid line is the biggest family, metals. This is a quite large group, and it's everything to the left, everything that you see shaded in color here. To the right of the line is nonmetals. This is the greens and teals and light blues that we see here. And in between them, on the line, except for aluminum, we have metalloids. Now, some people think that metals means anything that's a solid and nonmetals is anything that's not a solid, liquids and gases, but that is not true. Any metal can be turned into a liquid if you heat it up enough. Now, as you can see here on this periodic table, all of the elements written in black are solids at room temperature, about 70 degrees Fahrenheit, about 25 degrees Celsius. But as you increase the temperature, you can see more of them are starting to turn to blue. Those would be liquids. And then even more, and then as we continue to increase the temperature, some of them are starting to turn red, which would be gases. So if you increase the temperature, everything can turn into a gas if you increase the temperature enough. If we go back down to room temperature, we see how it is for us usually, which let me fine-tune this here. Let's see. Well, 68. We'll go 68. Back to normal. So now the nonmetals, they can do the same thing. The ones in red are gases, and blue bromine over there is a liquid. But if we go back down, we can get them to solids as well. So it has nothing to do with solid or liquid or gas. It just has to do with the groups and how they react with each other. Metals are on the left of that stair, nonmetals to the right of the stair, and metalloids are on the stair. Now, there are specific groups as well. This group, the first group of the metals, these are the alkali metals, and the alkali metals react violently with water. They will explode in water. And then the alkali earth metals are the ones to the right of them. They're more flaky and softer, and they tend to bubble up in water. They form gases. They react with water to form a hydrogen gas. The lanthanoids and the actinoids, for our purposes, we're just going to group those together with the transition metals. And these transition metals are sort of what we consider our typical metals: copper, silver, gold, platinum, nickel. These are where we consider our typical metals to be. And then we have post-transition metals. Post-transition metals are a little bit softer than transition metals. They have a lower melting point than transition metals, but other than that, they tend to have properties of transition metals. We have our general nonmetals here, and don't forget hydrogen floating over there with the alkali metals. We have halogens here, and when you pass electricity through these guys, they glow really brightly, and for a while they were commonly used in lamps, but they were fire hazards, so those fell out of favor. And lastly, we have our noble gases, which are interesting because they have a tendency, they do not react. They don't react. They don't really form molecules with any of the other elements up here on this table. So that is our general introduction to the families and groups of the periodic table. We will continue to refer to them throughout the school year. I hope this helps, and struggle well.